Yeah, the Earth's magnetic field is produced by the motion of the material at the Earth's core. It's a it's a molten material that moves around a lot, and as it moves, it produces electrical currents. And ultimately, magnetic fields are produced by these electrical currents. So it's really the dynamic motion of this molten material in the Earth's core that produces the magnetic field around the Earth that extends out into space. The core of the Earth, of course, the motion there can change over long time scales, which will produce some of the long-term changes in the Earth's magnetic field, even reversals of the magnetic field. What we study, what we're more interested in, is the more rapid changes in the magnetic field, which are produced by interactions of the Earth's magnetic field with the solar wind, which is produced at the sun and transported out into space. So it's that interaction between solar particles, solar magnetic fields, and the Earth's magnetic field that produces some of the more rapid magnetic field variations. The Earth is surrounded by an ionosphere, which is kind of a conducting layer. It's a layer that transports electricity in the same way a wire does. And so the Earth is really part of a big electrical circuit that extends out into space and even connects with the solar wind itself. So any kind of changes in the current system imposed by the passage of the solar wind gets transported into the ionosphere. And those currents, some of them can be very large, they can change very rapidly, and there's coupling mechanisms where those currents can actually change the currents in power lines, in pipelines. Any long conductor on the surface of the Earth can feel variations and respond to variations in the ionospheric current. The only way you could possibly see it more commonly is in the behavior of a compass. Some of these magnetic field variations can actually be apparent in kind of jittering or deviations in compass pointing directions. I find this a very rewarding job because there are so many things that we don't really understand. There are so many things that remain to be learned. And the most rewarding times that I've experienced is when you see a phenomenon and you go back and you look at the data and you study it, you read other papers, you talk to other people, and all of a sudden it becomes clear on what the origin of that feature is and what causes it. And that when you get to that point of enlightenment where you really understand something, it's a tremendous feeling of accomplishment. I would definitely encourage young people to go into the space science field because it's definitely an area that's growing. I mean, I think everyone admits that the future of humanity in general lies in our ability to make use of space, to feel comfortable living in space, and perhaps in the distant future to be able to set up colonies on different planets and different the moons of some of the other planets. These are all very exciting and futuristic concepts, but to do that, we really have to understand the environment that we're going to go into. And I feel like I'm contributing to that.